Solving. Two. Step. Inequalities. We're solving two-step inequalities today. At the end of this, hopefully you can confidently say, I can solve two-step linear inequalities with one variable. What that means is there's no exponents in the inequality, and there's just one letter. There's one letter. There's not multiple letters. Again, this is a 7th grade version of things. It's very similar to solving two-step equations. Just now we have inequalities. We just have a different symbol separating the two sides now. But again, we're going to be solving them the exact same. It's just now that we have to graph our answers because there's more than one number. So let's go through our vocabulary and remind ourselves of what these things mean. We want to use inverse operations to isolate the variable. That first vocab word, inverse, means what again? Opposite. Inverse means opposite. That word here that they already bolded for you, isolate. What does isolate mean? To get alone. We want to get our variable alone using opposite operations from what we see. On our last set of notes with one-step inequalities, we had a special little bit different that we didn't have before with equations. A little extra step that we have to look at to do. Remember, if you multiply or divide both sides by a negative number, you must flip. I'm going to write that in all capital letters. You must flip the inequality symbol. So if it was less than, it's going to be greater than. If it was greater than, it's going to be less than. If it was less than or equal to, it's going to be greater than or equal to. If it was greater than or equal to, it's going to be less than or equal to. We're just going to change the direction of our sign, but it has to be both sides is key. It's got to be both sides. Let's just get into it. Before we even get started, before we do any math, there were two things that we like to draw on our equations, and we're doing the same thing with inequalities. What were they? The train tracks, and we want to box our variable and its coefficient, the number in front. I want to protect that. I want to save that for last. That box helps us remember to save that part for last. So what do I need to get rid of here to help isolate my variable? I need to get rid of that -5. I have to do the inverse. I have to do the opposite. What's the opposite of -5? +5. And again, I have to do it to both sides. I have to do it to both sides. -5 and a +5 are opposites. Opposites eliminate each other. Bring down your 6a. -23 plus 5. If you're not confident in that, there's no shame in the calculator game. -23 plus 5 gives us -18. -18. Now, again, I need to isolate my variable. I want to get the letter all by itself. So I need to get rid of that 6. What operation is happening with that 6 and that a? That is multiplication. There's a little invisible multiplication symbol in there. A lot of people want to subtract 6, but that only works with addition and subtraction. I have to do the inverse, the opposite operation. The opposite of multiplication there is division. So I need to divide both sides by 6. Divide both sides by 6. Those 6's are opposites, so they cancel each other out. I bring down my a. -18 divided by +6. Again, no shame in the calculator game. -18 divided by 6 gives me a -3. And now we need to pause and think. Is our sign going to flip? Yes or no? Why? It should not flip. Both sides I divided by a positive 6. If this 6 was negative, then I would flip. But because I do not have a negative that I'm multiplying or dividing, my symbol stays the same. 18 being negative, that doesn't matter. It has to be the number that's on both sides. So here we get A is less than or equal to negative 3. My rice is done. Thanks, Instant Pot. Oh, there we go. So now we know our answer needs to be with a dot on negative 3. Open or closed? It's going to be a closed circle. Why is it a closed circle? The line underneath, we talked about on the last set of notes. If our symbol's extra, if it has that line underneath, we have to be extra with our circle and fill it in. And now's the tough part. Do we shade to the left or do we shade to the right? Like we talked about again with our last set of notes, it helps to think about what number would be on either side. A is less than or equal to negative 3. Less than means that my numbers are going to be smaller or bigger if they should be less than negative 3. They should be smaller than, so we should shade to the left. We should shade to the left because it's less than negative 3. And we can check our answer too. We talked about this. So let's say we have negative 20 that's over there. We can substitute that in for A. Is negative 20 less than or equal to negative 3? It is. If you need to, take a look up at the number line in the classroom. Think about that when negatives, yes, 20 is bigger than 3, but negative 20 is less than negative 3. Our numbers flip directions when we go negative. Woo! So again, our answer was A is less than or equal to negative 3. It's the same steps, but it is a little bit more work compared to what we had last unit. So bear with us. Bear with us. Ooh, I'm liking this number 2. It's going to get a little tricky. What should we be drawing on our page before we even do any math? We want to draw our train tracks, and we want to put a box around our coefficient and our variable. What am I trying to get rid of first? That positive 4. I need to get rid of the number that's on the same side as my variable. I need to get rid of that third wheel. How do I get rid of a plus 4? Minus 4. The inverse of addition is subtraction. So my plus 4, minus 4 are inverses. They cancel each other out. 14 minus 4 is 10. Bring down my minus x. Ooh. Negative x and 10. Do you see a number in front of that x? You don't see it, but what is really there? Math people were lazy. We work smarter, not harder. Math people here are being lazy. They don't want to write that it's a negative 1 in front of that x. They don't want to write that there's a negative 1 in front of that x, and let me show you why. If I take negative 1 times x, that's just going to give me negative x. So what they're doing is they're simplifying that multiplication into just a negative x. So that's what you saw before. There's an invisible 1 up there that math people are just simplifying and they're not writing in front. So that's what's going on there. What operation is happening with that negative 1 in x? I'm not adding 1 to both sides because just like over here, they're really being multiplied together. They are really being multiplied together. So I have to do the inverse. I have to do the opposite of multiplication, which is division. We are dividing both sides by a negative 1. We're dividing both sides by a -1. Something crazy is about to happen. If we divide both sides by a negative number, we must flip the inequality symbol. Both sides are getting divided by a -1, so we need to flip our inequality symbol. It was less than. It needs to become greater than for our answer. Our inequality symbol is flipping because both sides got divided by a negative. My -1s cancel out. I bring down my x. 10 divided by a -1 gives me -10. So we get x is greater than -10. X is greater than -10. So let's put in our -10. Is this going to be an open circle or a closed circle? Open. There's no line underneath, so that means it's going to be an open circle. Here, line underneath means it's closed. No line underneath means it's open. And are we going to shade to the left or shade to the right? For numbers where x is greater than -10. X is greater than -10. Let's think about where +10 would be and try plugging that in to see if it works. Is 10 greater than -10? Yeah, it is. So that means we should shade to the right. That means we should shade to the right. If I try to choose a number like -20, is -20 greater than -10? Again, it might look like it because 20 is bigger than 10, but with negatives, the numbers change order. So this is not true. We should shade to the right. Number 3 looks just like number 2. Take that skill, that information you just learned about that coefficient really being a -1, and try just solve it. Don't graph it yet, just solve number 3. Just solve number 3. Did you check to see, do you need to flip your sign or not? Why or why not? Pause and double check. Boom! The first thing you should do is box your -x and then put your train tracks. And then you should Am I still recording? I was trying to do a TikTok thing. I don't know. I think, yep, messed that up. Good try, Miss La Rosa. All right, so now you need to subtract 8 on both sides. So we end up with -x on one side and +8 on the other. Like we talked about, there's that invisible 1 there. So we need to divide both sides by that invisible -1. Those cancel. I get x. I get -8. And my sign flips. Why does my sign flip? Because the negatives that I'm dividing on both sides, that's what causes the flip. That's what causes my flip. So I get x is less than -8. So we know we need -8 on our number line. Think to yourself, am I going to shade to the left or am I shading to the right? And why? Pause the video. When you have your answer, unpause it, see what you did. Hopefully you shaded to the left because the left is less than, x is less than -8. It's smaller than -8. Smaller numbers are on the left side of a number line. All right, now we're going to have you try number 4 all on your own. Pause the video. Good luck. A should end up being less than or equal to -3. We start off subtracting 12 on both sides. When you bring down, that subtraction sign needs to stick with that 11. that operation sticks with the term behind it. So it needs to become negative 11a and 33 on that side. Divide both sides by a negative. Our sign has to flip again. So we get a is less than or equal to negative 3. Because a is less than, that means smaller than. Smaller numbers are on the left side. If you have any questions on that, let us know. 5. I'm going to have you do it on your own. I'm going to have you try that on your own. Real quick reminder, what does that fraction bar mean again? That fraction bar means division. So when you're going through and solving to undo that division, what is the inverse of division? Multiplication. Pause the video and give it a go. So the first part, just subtracting by 9 on both sides. Negative 36 minus 9 is a negative 45. Be careful. Double check your work before you keep playing to see if you get the whole thing right. And again, x and 5, those are division. The inverse, the opposite is multiplication. So you should be multiplying both sides times. You should end up with x is greater than negative 225. The sign does not flip here. The sign does not flip here. Both sides were multiplied by a positive number. We only flip if it's negative. We only flip if it's negative. So we multiply both sides times 5. X is greater than negative 225. So we should be shading to the right with an open circle. I'm just now realizing up here we didn't do the circles. I just started shading. This circle should be open because there's no line underneath. This circle should be closed because there is a line underneath. Hi, Jackal. Do you want to say hi? Come here. Come here. Say hi. Come here. Hi. Look at this good boy. Look at this good boy. I'm almost done and then we'll get you your food, okay? He's hungry because it's dinner time. Okay, you gotta go down. I gotta finish. Just a sec. All right, I'm back. He's still there creeping though. He wants his food. He's hungry. He'll live. It's only 5 minutes past dinner time. So, last problem. Negative 22 is less than x plus 4 over negative 3. We've seen problems like this before on some practice, but we really haven't talked about it, gone over it with you. I know I pulled a few of my kids for a small group and we talked about how to solve this, but not everybody has seen it yet. Remember how we talked about going through and doing order of operations? We did GEMDOS. But remember, now we have to work backwards through our order of operations. We have to do addition and subtraction first, multiplication and division last. But now, so instead of GEMDOS, we do SAD-MEG. SAD-MEG. In a fraction like this where you have math on the top or on the bottom, this is considered a grouping piece. This is a group. And in SAD-MEG, where do we do groups? Groups are last. The groupings is saved for last. So I'm not subtracting 4 first. That's part of grouping. That's not happening till the very end. In this problem, I need to start off with my division and multiplication. I have to get rid of that negative 3 first. So with that grouping, that's what we would want to box now. We want to box that special group on top, and we need to get rid of that negative 3. What operation is happening with that negative 3? Division, because it looks like a fraction. Fraction's division. So we have to multiply both sides times a negative 3. What happens when we multiply by a negative? Our sign is going to flip. We multiplied both sides times a negative 3, so our sign needs to flip. Negative 3 times negative 22. Let's get our calculator going. Negative 3 times negative 22 is a positive 66. Positive 66 on this side. Those negative 3's cancel. We bring down our x plus 4. And now I have my variable plus 4. I need to get rid of a plus 4. How am I going to do that? Minus 4 on both sides. What's 66 minus 4? 62. And we have x. We have 62 is greater than x. So on our number line, pause the video, try shading it on your own. We should have an open circle on 62 because there's no line underneath. We only shade it in when there's a line underneath. And we should go to the left. 62 is greater than x. 62 is greater than x, so x should be everything smaller than 62. I know this was a long set of notes, but we just need a lot of practice recognizing if we need to flip the sign. We need lots of practice recognizing how to graph because that gets a little tricky too. So on the back side, we've got some practice problems for you. Please let us know if you have any questions. If you want us to check after you try one or two on your own, let us know. We'll be more than happy to do that for you. Good luck, guys.